All right, guys, welcome everybody. So let's dive into a crucial component of the AWS Certified Machine Learning Specialty Exam, MLS-C01. The domain is titled the Data Engineering Domain. Okay, this represents 20% of the exam content, as I said earlier in the last section. And while the percentage might seem modest, it is important. Its importance cannot be overstated. Okay, this is the foundation. This is the building block. Think of data engineering as the foundation of your machine learning house. So you have to have a solid, you know, you need to have it solid so you can stand tall buildings on it that are safe, that can scale, right? So let's just start with data repositories, which are at the heart of this domain, okay? So AWS offers multiple storage solutions, each with its own strengths, okay? So Amazon S3 is often go-to for storing large data sets. In my demos, that's what I will be using as well. Well, Amazon RDS might be your choice for structured data. So if you have structured data and unstructured data, structured data, you could put it in RDS, right? When designing these repositories, you need to think like an architect, okay? Consider not just today's needs, but tomorrow's scaling requirements, okay? The questions you should always ask, how will my machine learning models access this data? What is the experienced query pattern, right? What is the expected query pattern? Where would the queries start from? How frequently will the data be updated, right? These considerations will guide your choice of a strong solution. Moving on to data analysis and visualization, while these topics technically fall under domain two, they are inseparable from data engineering. So let's break this down into practical terms, okay? So first, you'll need to master various visualization techniques. Think of scatter plots or your detective tool for identifying relationships between variables, right? The time series plots help you understand patterns over time, so crucial for any predictive modeling. Histograms give you the story of your data's distribution, right? While box plots help identify outliers and understand data speed. So, but visualization is just the beginning, okay? You need to speak the language of statistics, understand correlation coefficients, p-values, and summary statistics. These are just theoretical concepts. They are your tools for making data-driven decisions. Okay, if you're not familiar with these, don't be alarmed. Don't You're not going to be a mathematician at the end of this course. AWS provides you a lot of uh, you know, easy to use, no code options that as long as you understand what you're doing, you should be able to do it. All right. Cluster analysis is something important for this domain as well. So, if you talk about cluster analysis is pretty fascinating, right? It's a fascinating area where your starts telling its own story, right? Hierarchical clustering is like creating a family tree for your data points, okay? Showing how they relate to each other at different levels of similarity. Okay? The elbow point, despite its simple name, is one of your most powerful tools for determining the optimal number of clusters. Okay? It's like finding the sweet spot between oversimplification and overcomplication of your data. All right. So you don't want to simplify it and you don't want to complicate it either, right? So elbow point is sort of like a middle ground there. All right, so what does AWS expects from you, right? AWS expects you to bring substantial real world experience. They say that you should have at least 2 years of experience to the table, right? Specifically, 2 years of working with ML workloads in AWS Cloud. So this isn't just about knowing the theory; it's about understanding the practical challenges and solutions. And that's why I've curated this course in a way that it presents you challenges in all of my frontline stories, all the real life use cases that I will discuss with you. These are frontline stories, right? You need to know them. You need to immerse yourself in these stories and then try to understand, hey, do I have a similar problem? Or does the business that I work for has a similar problem or no? And like I said, it's practice, practice, practice. You should be comfortable with the intuition behind basic ML algorithms. Okay, so this means understanding not just how they work, but why they work. Okay, so hyperparameter optimization isn't just about grid search. Okay, that's a topic we'll cover later on. It's about understanding how different parameters affect your model's performances. So it's like, if somebody's taking a heart medication, there may be a side effect if they were getting some over-the-counter flu medicine, for example, right? I don't know this for a fact, but I'm just, making it up. So if those were the effect, basically during hyper parameter optimization, you will realize that relationship is breaking. Okay. You need to have a working knowledge of ML framework. Well, it's not optional. You don't have to have a very deep level knowledge, but you should understand whether it's TensorFlow, PyTorch, or SageMaker's built-in algorithm. To start out with, that's what we're gonna play with, is built-in algorithms. You need to understand their strengths and limitations. Okay. So to wrap up, remember that data engineering in the context of machine learning isn't just about storing data. It's about making data accessible, clean, and ready for analysis. Okay. And your success in this domain requires a blend of theoretical knowledge and practical experience. So as you prepare for the exam, focus on understanding why behind each concept, not just what, right? Why. This understanding will not only help you pass the exam, but will make you a better ML practitioner. Okay. Thank you for your attention and good luck with your certification journey. I'll see you in the next lecture.